Hey there, welcome back. So here we have a question. Again, this question is like the few others that I've done before. It's one of those that's not part of the selection that I gave you. Alright? So let's take a look and read it. It says, which of the following fractions is between 1/3 and 1/2? Like always, we begin by underlining words we think are very important. This one for certain is very important. And in math, between has a very specific definition. Between means that you are considering things in the middle of those two things that they reference. And so, for example, here, there must be many numbers between 1/3 and 1/2. But we can't include 1/3 and 1/2 as one of those numbers. So a simpler way of seeing this is like this. Ready? If someone says, how many letters are between A and D, the answer would be 2, because there would be the letters B and C. You would not include A or D itself. Whereas if they asked us, how many letters are there from A to D? That would be a whole different question, because then the answer would be 4. It would be A, B, C, D. See? So that's 4 letters. So there's a very big difference between the word between and the word from. So if ever you see the word between, again, they mean the things in the middle of those two other things that they're referencing. So in this case, if any of these fractions, when reduced, turn out to be 1/3 or 1/2, we can't use them. Alright, they're not usable. So between is very different from the word from. I'm sorry that it's so repetitive. It's that we're using the English language as we usually use it, and we're using it in combination with math language, alright? So sometimes they have like a overlap, right? Alright, so let's take a look. What can we do? This one already looks too small. Why? Well, first things first, let's look at 1/3. And let's make 1/3 be what? Go like this, 3 divided by 1. Let's convert it into a decimal. 3 divided by 1, well, it can't. How many 3's are in, well, I mean 1 divided by 3, you can't. So how many 3's are inside of 10? 3. 3 times 3 is 9. Bring that down, the 0 that you add. And you see that this is going to keep going, right? It's going to forever be like that. So we can say that 1/3, pay attention because I'm going to erase, and I know that I told you that was a sin. But let's be sinful for a moment. That's 1/3 as a decimal. Got it? Let's see what 1/2 looks like as a decimal. You do 2 divided by 1. How many 2's are there in 1? None. So you put a decimal point, you put the 0 there, and then you ask yourself how many 2's are in 10? 5. We kind of already knew that 1/2 was 0.50, right? That's why we say 50 cents is half a dollar. So now we go like this. Nice. So what we're asking ourselves are any of these fractions in between this and this? So at a glance, some of them already look wrong. Like this one here is less than 1/10, right? Because 1/11. So like if it was 1/10, it would be what? It would be 0.10, right? 1/11 is even smaller. So that's way too small, because 0.10 on a number line, if we have a number line here, and here we have 0.33, and here we have that, where would 1/10 be? And I know this says 1/11, but we're just treating it as if it said 1/10, just because 1/10 is even actually bigger than this is. This is even smaller than that. So 1/10 would be like here, right? And is that between this and this? No, it's outside of that. See? It's not between it. A would be like, who knows, somewhere like there. So it can't be A. How about this? Well, we say how many 13's? Well, you can't see that, so let's do it here. How many 13's are in 2? None. You go like this. 13 is inside of 20. You subtract. You get 7. You bring it down. And look, you don't need to finish the problem. Already the problem's going to be 0.1 something. 0.1 something is going to be, again, around here somewhere, right? We don't know, somewhere around here, somewhere around here, somewhere around here. So it's no good. Right? Because if it's 0.18, 0.17, it doesn't matter what it is. If it starts with 0.1, it's going to be smaller than 0.33. So already that's not included. So what do we do next? Let's move on to the next one. Here we are. Ever so sinful. and we do 15 divided into 3. Well, 3 divided by 15. No 15s fit inside of 3. We put our decimal point, we make it 30, and 2 fit in there. How about this? It's still too small, isn't it? That's like right here. So that's not good either, because it has to be between 0.33 and 0.50. Now, here's what's very helpful. When something says which, they mean there's only one answer. So we have 2. If one of these turns out to be the answer, stop there. That's the answer, because we know we can't have 2 answers when questions start with which. All right? So let's do 17 and then 7. How many 17s are in 7? None. You put a decimal point, you erase it. How many 17s are in 7? 4. 4 times 17 is, let's see, 4 times 7 is 28. 4 times 1 is 4 plus 2, 6. Right? And then we get 2. Bring it down. Right? Let's see. How many 17s are in 20? 1. Aha! Is 0.41 between that? Yeah, it's like right here somewhere. 0.41. Right? Actually, no, it's actually somewhere around the middle. So it's actually a really good one that they gave us. It's like right here somewhere. And we got it. And that one is letter D. And letter D is our answer. Okay? So you know your answer right away. You have to become familiar with what fractions look like when they turn into percents and when they turn into decimals. Becoming more familiar with what fractions look like in their other forms will help you get questions like this right more quickly. And that's what we have to do. We have to become fast at doing this, okay? And so look, I was able at a glance to eliminate this, this one as well, really. And then this one too. And I'll tell you why. Because if this was, it is 13, and if this was 26, it would be half itself. But in fact, here, how many 13s squeeze into 23? 1 does. But actually, 13 is more than half of 23. So this is going to be a fraction that's already bigger than 0.50. Let's actually do it if you want. We do 23, and we do 13, right? How many 23s are in 13? None. We put our decimal place, we lift it, and then how many 23s are in 130? I would guess, if we treat it like it's 25, I would say 5. 5 times 3, 15. 5 times 2, 10 plus 1, 11. So, look, 5 times 23 is what? We said 115. And that would give us 15 as a remainder. How many 23s are inside of 15? Well, let's see, 5 times, yeah, so far so good. So, 0, and then you add a 0 here, you bring it down. And then how many 23s go on 150? Wow. Let's say 6. 6 times 3 is 18. 6 times 2 is 12. Plus that one, 138. Yeah, that was a good guess. But look, it's close, right? It's so close. But it's over it because it's 0.506. And even if it would have been 0.50 itself, like this, it still would have been wrong because the question says between. It has to be between the numbers. It has to be between this and this. It can't be this or this itself. So this here is too big. It's just a little too big. But even if it were equivalent, it would still be no good because it has to be a number that's firmly between 0.33 and 0.50. Alright, so that's that. Again, to get these kinds of questions right, I need you to become more and more familiar with what fractions look like when you turn fractions into decimals and decimals into percents. This has to be mastered, alright? Until next time.